Hi, my name is Bruce Crayenhoff, and in this screencast I'll be going over Lesson 3, Improving Reliability with MyPy and Type Hinting. This is based on Raymond Hettinger's course, Modern Python Live Lessons, Big Ideas and Little Code in Python. So on O'Reilly Safari you can find the original course. We're just looking at Lesson 3. And so what we're going to look at first is we're going to look at the code and see what we can learn from that. Alright, so here's the code. So first of all, a note about type hints here. You can see that this says that this is an iterable and that each element of that iterable is a float. And so that's the data coming into this function, and the data leaving the function is just going to be a float. So there's quite a bit of flexibility in type hinting in Python. So this is fairly specific. We could be more general and say, okay, it's just an iterable, right? It's got stuff in it. We're not telling you what the stuff is, but you can iterate it. Or we can say it can be anything, which basically says, don't do any type checking at all to your tools, because this could be anything. Cool. So fsum. So fsum, you can import it from the math module. It's like sum, except it's got more precision for math. I think this would only occasionally be valuable, so maybe not worth learning. Now, here this is specifying, okay, this is a tuple. Each element of the tuple is a float, and it can be of any size. That's what the ... means. So rather, we could take this and we could, put that in both of those locations, but that's kind of verbose, right? And this tells you, a point means more to a human, right? So we can just, create a new variable point, which means this, and I don't know, it's much more readable, much less verbose. Let's see what else. Cool. So here again, this is an example how with graduated typing in Python, you can be very specific about what exactly your function accepts and what exactly it returns. So here, this is saying it's a sequence. A sequence is something you can iterate over more than once. You can also slice to a specific location in it. So a sequence is a lot like a list, or like a string is also a sequence. The data is just an iterable. Now an iterable, you might only be able to iterate over once. Okay? So we're being very specific about what these can be. And what we're returning, we're not just saying that we're returning a dictionary. That dictionary, the keys are centroids, and the values are sequences of points. Cool. So now I also thought this was noteworthy. So here we're doing a minimum over centroids. But then we say the key is this partial function, so we've already put the point into it, and so then it will end up just being this distance function between the point in question and all the centroids as it goes through and does, calculates all of these to find the minimum. And so this will actually return basically the argmin. So this is like the argmin over the centroids of the distance from each centroid to the point. So I'm trying to do like math notation here. So that's essentially what we've done by using this key here. So a clever way to do an argmin in Python. Let's clean that up. And we'll have more look at this here. This is telling MyPy to ignore this. Moving on. Cool. So here, this is actually a modification that I made. This is not in the original code. we could just take this and plunk that right in here, right? And then we wouldn't need that line. But I find this a little bit hard to parse, right? Like, what exactly is all this doing? I have to look at it in detail. With one use for lambda functions is that we can extract out logic. Just like if we have a value, we can use a variable name to extract it out and explain it. With a lambda function, we can extract out the logic and give it a nice name like getCentroid. And that makes this list comprehension much clearer, I think. All right, cool. So I think we'll look at this more later. So here, this is telling us this is an integer, and the default value is a 2. But MyPy, and presumably other tools, are generally smart enough. They will infer the type. If you say k equals 2, it will infer that k is an integer. So then you would only need a type hint if k isn't always an integer. So yeah, the tools are fairly smart, so we don't need to be so verbose and type hint everything that has a default value. Cool, I think that's about it. This code is, worth going through yourself. It's on the GitHub repository that goes along with this course. So yeah, I recommend looking at it and spending a bit of time digesting it for yourself. All right, so now we're going to look at type hinting specifically and using some linters. So first of all, why would we want to use type hinting? Well, first of all, type hinting is documentation. Whoops. Type hinting is documentation, right? So by adding types, it makes it clearer, what the inputs are supposed to be, what you expect to get out, and this makes the function easier to use without digging into it. I find this form of documentation helps me think as I'm designing something. I can just, it helps me think of the high level here. And then I can collapse the rest of the function and just have access to that level of information about the function. I definitely find a lot of libraries now use type hints, and I certainly find that helpful when the little pop-up in PyCharm shows each of the parameters and what the type is. I certainly find the types helpful. So another use for these type hints is that we can do static type checking. So the most important form of kind of automated test is your unit testing, right? Or other kinds of integration testing, functional tests. So that can test exactly what you intended to do, right? So that's the most important one, but it's also fairly time consuming, right? Well, static type checking, it doesn't take that long to add a few types to your code. And it actually checks for some stuff here that you don't usually get at with your unit tests. So these don't entirely overlap, so you have a fairly inexpensive approach by adding these types of detecting some different errors that might otherwise take a while to debug. So I mean, most large projects use statically typed languages, which are not so flexible like Python. And so JavaScript is dynamically typed like Python, but there's TypeScript and there's something else that Facebook came out with. So they've got graduated typing schemes as well for JavaScript. And one study found that they spent about 15 minutes. They just added some types to some repos, and they were able to find like 15% of the bugs in those repos just by adding types, right? So not that expensive, and yeah, it can find some bugs. All right, so how can we do our static typing? So basically, we can just run MyPy, that's one option, and we give the path to the file. So let's do that. So I'll copy the path to this file, switch to the terminal. hold on a second here. All right. I don't want to run that. There we go. Oh, there's no issues there, right. That's why I added some issues in this version of the file. All right, and it has found 2 issues here. So in line 34, so let's look at line 34 here. Cool, so it's returning this. All right, so I told it this is a float, and it's saying this is a dictionary whose keys are centroid. So that's why it's giving me an error here. So I can fix that. And 35. So that's here. It's expected that I'd return a mapping from a string to something, and I have this is from a centroid to something. So I also need to fix that. Cool. And then if I run it again, it'll all pass, right? Cool. Fairly straightforward. All right, so there's also tools in PyCharm and probably in other editors as well, which will do some type checking for you. So let's do that as well. Let's undo my fixes here. All right, and we go to Code, Inspect Code. Now this will do a bunch of inspections, including some type checking. So this is the one I want. I'm not sure what's going on here. All right. Yeah, so this isn't finding anything. So MyPy certainly has a lot more type checking functionality than PyCharm does. PyCharm has a bit built in, but not as extensive as MyPy. The first time I ran it, it came up with an erroneous error, and I disabled that check because it wasn't checking things correctly. Yeah, so that's how you do that. Go to Code, Inspect Code. That runs PyCharm's type checking and other lints and PEP8 checks. All right. Now, what should you add types to? Obviously, a downside of types is it's making your code more verbose. An upside is, the documentation and the automatic checking. So we want to add as few types as we need to have clarity for ourselves and for the type checker, basically. So you can do this, but this is really unnecessary. Because of the default value of 2, we know that k is going to be an integer, right? And MyPy can infer that as well. And so this is better. There's no default value for data, so it's good for us to specify the type. As long as this is good enough, then sometimes maybe we could put none for this, in which case then we should put in types to explain to MyPy that this is in fact an optional argument, even though it has a default value. But in general, the default value tells you what the type can be, and so you don't need to annotate the type there as well. So that's the main place that I would annotate types, for the inputs and the outputs of functions or methods. Now, occasionally you might want to annotate in other places. For example, if it helps you think as the programmer, do it. If MyPy requests that you add a type somewhere because it can't infer the type, then I do that to help MyPy out. And sometimes MyPy infers the incorrect type, right? In which case I can again specify the type explicitly so that MyPy is doing what I want, right? Is checking what I want. Now, so that's what to type, or where in your code to add types. Now, when in the programming process should we add types? This is all my opinion, by the way. So, I mean, I would add them if they help you program, right? I would add them if you want MyPy to help you find a bug, you know. That's a good time to add some types. And otherwise, you know, maybe before each pull request, because you don't really want to, you know, add types to a bunch of stuff that you're going to change and ultimately slow down your coding. So I wouldn't necessarily try to add them early on unless they're helping you out. But before the pull request, yeah, you can add the types, and then you can have MyPy run with more type information and catch more bugs. And have better documentation for other programmers, your reviewers, for example. Now, sometimes you want to do something really dynamic, right? And so it's really hard to get the types right such that all the checks work and MyPy is happy. From experience, I found this happens sometimes. So there's a few strategies that you can use. You can just use a comment to tell MyPy, you know, ignore this, right? Don't worry about this. You can also give something the type of any. So this means that this could be anything. Don't type check it. I'm doing something very dynamic here. So in general, like when you run across, you know, it's hard to figure out how to type something. You know, I'd just do something like this. Don't slow your programming down too much. I remember hearing Bob Martin say that dynamically typed languages like Python, they allow you to code like 4 times faster. So you might degrade the quality a bit, but you get much more speed. Well, I don't think we want to lose that speed, right? So when you need to do something really dynamic, you know, use one of these solutions so that the type checkers are not slowing you down. But you know, 90% of the time you aren't doing something super dynamic, so you might as well use type hints and benefit from everything that types offer you. All right, so we're also going to cover linting briefly. So linting is just more generally automatic checking for common errors. So MyPy is just for type-related errors. Linting is more general. So there's a few linting tools we can use. This is not exhaustive. So PyFlakes is a fast linter. That's the great thing about it, I'd say. PyLint is quite slow, but it's thorough. It will lint for everything. You'll probably want to customize it a bunch so that you can tell it to stop reporting a whole bunch of useless errors. You know, depending on what standards you like to follow in your project, a lot of the errors might not be useful, right? So let's try these. So PyFlakes. Switch to this one. So very quick, it didn't find any issues. Let's create an issue. All right. Okay, it found the issue. And so let's do PyLint. So we're going to PyLint. So I'm disabling searching for conventions. That's like your PEP8, and I don't want it to give me a huge number of errors. So that was actually fairly quick for this, but often PyLint takes, you know, can take like 10 seconds. Let's try disabling. Oh. So I think what's happening here is it's finding the error, and then it's kind of stopping the rest of the lint because it says, okay, there's a syntax error. I don't know how to make sense of the rest of your code in order to lint it. So if we remove that syntax error and we lint it again, okay, so now you can see some of these are convention checks. Oh, there's a naming style. It says, okay, this is a variable. They're supposed to be snake case, not uppercase. But this is actually quite reasonable because this is a type. It's not an ordinary variable. So we might want to silence this kind of error. And you see here the W colon, that means this is a warning that there's this unused variable here. So maybe we want to go there, and yeah, we're not using that, so the convention for that would be to use an underscore instead to say, yeah, I want to throw that variable away, basically. Yeah. All right, and I'll undo those fixes. Let's add back the syntax error. And all right, since PyCharm has built-in linting, I imagine some other editors do as well. Also some editors you can get, like maybe PyFlakes or PyLint running in the background, and then the editor will somehow display the results. So let's go here. Again, we just go code, inspect. Yes, that's the current file. And it finds 2 errors. Return outside a function, that's because of that error. Okay, and it figures out, okay, let's rerun it. And it's got a bunch of weak warnings. This is all your PEP8 warnings. Oh, shadowing a built-in. I mean, sometimes we've changed the definition of zip. This is intentional here to speed things up computationally, but this zip here is referring to this zip, which could end up being different than the built-in zip, which could be, shadowing a built-in is usually not useful. In this case, it's intentional. Yeah, so anyways. Oh, single quote. Oh, that's interesting. So usually we have triple quotes for docstrings, not single quotes. So it'll find all these things. If yeah, this or PyLint conventions will also find all these things if you want to, have certain standards like following PEP8. PyCharm and PyLint can both be very helpful tools. All right. So why lint? Well, again, it's fairly easy, right? With linting, you don't even have to add types. You just run some external tool. Maybe it takes 10 seconds to run. That's about the extent of the burden on you. And again, it catches some errors that your tests probably won't. There's some bugs that can actually be very hard to find, but other people have found that bug before in different code, right? And so they put it into the linter, and it can actually catch that bug for you before you waste a whole bunch of time trying to debug it, right? So yeah, linting, again, I mean, it doesn't catch that many bugs, but it will catch some of the bugs very easily. So I think it's, again, a nice addition to your tool set. Yeah. Now, so I want to mention you can actually also integrate these linters with Git. So when you do a Git commit or whatnot, you can have it automatically run your PyFlakes or certain linters, and then it'll only let you commit unless you override it. It'll only let you commit if it passes everything, right? So if you forget to use it and you want to use it, you can integrate it into Git. These also integrate into your editor or your IDE. So I mean, you can maybe have PyFlakes running in the background along with Sublime Text or Atom or Visual Studio Code, and you'll get little squiggly red lines like this based on the results of the linting. And you can also, if you have a terminal kind of connected to your editor, you can set up running these lints in that terminal so that you then have a link here that you can just click on to go straight to the point in the file where you need to make the fix. So I have that set up in PyCharm because PyCharm's lint doesn't seem to be as exhaustive as some other linting tools. All right, and that is it. Thank you for watching this presentation. Bye-bye.